Hello everyone. Today let's see today's daily question number 2661, 2661. First, completely painted row or column. You are given a zero index array ARR and an M into N matrix. Both contain all integers in range 1 to M into N. Go through each index I in array starting from index 0 and paint the cells in matrix containing the integer array of I. Return the smallest index I at which either a row or a column will be completely painted in matrix. Now let's go to the given examples to understand the question more briefly. We are given an array which contains numbers from 1 to 4 and a matrix which has numbers 1 to 4 but in rows and columns. Now, while we are traversing the array, say we are at index 0, we are at index 0, we are having 1 as element. So we first paint 1. Then we are having 3, we paint 3, then 4, then we paint 4. So at index 2, we are able to color a complete row or a complete column. One row or one column is completely painted. In the similar way, example 2. While we are traversing from index 0, when we reach at when we finally paint 4, when we finally paint 4, we are able to completely paint this column. So that's okay for us, right? At index 3, we completely painted a column. So we return that index 3. Now let's look into the constraints. M is a matrix length, N is a column length. Array is of size M into N. Okay. M and N are of size less than or equal to 10 power 5. M into N is less than or equal to 10 power 5, which means that maximum array length is 10 power 5, right? Array of I is lies between M to N into N and 1. All integers, all the integers of array are unique and of matrix are also unique, right? These are the constraints given. Now, let's think of a possible solution. Let's move on to our notepad. We are given with an array and a matrix of size M into N, right? This is of length M into N. So we'll first consider this element at index 0, search for this element. Searching for this element may take a big O of M into N time complexity, right? Which is at max 10 power 5. And here also we do have 10 power 5 elements. So if we go in this fashion, our time complexity would be 10 power 5 whole square. So we need to optimize the way we search for the element. What if we store position of the element here initially itself, right? That's our take. So we consider using a hash map wherein we store this element as key and position position array of row comma column has value in this map. Using this hash map, when we have traversing in this array, we consider this element, we would be able to get position of this element in big O of one time complexity. So we initiate and size of this map would be 10 power 5, which is feasible. In this way, we write our code. And what's our goal? First row or column to be painted. Right? This is our goal. So we initiate array for row and a array for column. Initiate this row with columns and this column array with rows, number of rows, and number of columns and number of rows. Right? Now, whenever we are at this row, we decrement this, and whenever we reach this column, we decrement this. And whenever we reach our count at particular row or column to zero, we return that index. This is the intuition of our code. Now let's move on to the code part. Now moving on to the code part, this is our code, which says we initiate a hash map to store integer and an integer array. We take rows and column size, and for every element in matrix, we store the position of that element into the hash map, right? Then we initiate rows to uh, number of columns and columns, number of columns to number of rows, right? We start iterating in array. We get the position of the element in array and decrement the row and also the column. If we get it equal to 0, we return the index. To complete this code, anyhow, we'll be getting an answer here. To complete the code, we just write a return statement to -1. Let's run the code and check. Yeah, we're happy with the sample test cases. Now let's submit it. Yeah, we are happily submitted the code. It works for all the test cases. That's all for today's question. See you another day with another problem.